Okay, good morning everybody. So today we will talk about the inheritance and polymorphism of Java, starting from that point, and we will continue our discussion with Java. We talked about polymorphism last time. We said that polymorphism is a very integral part of the Java programming language. In fact, all the public methods by default are polymorphic. So the default behavior is polymorphism, as opposed to C++'s default behavior of early binding functions. So whenever you write any method, public method, it is automatically resolved during the runtime, not during the compile time. So this kind of overhead of method calls in Java always exist. So as a C++ programmer, we are kind of careful about this. If you don't like this behavior, there are some methods to prevent this behavior, and we are going to see. So we looked at this polymorphic behavior by giving this main by giving this method. We said that, remember, we have this commission employee. This was a simple hierarchy, and extending from commission employee, we have base plus commission employee. Okay, so that was the case. So I have a new commission employee object. Its name is commission employee, and I created it. I constructed it with commission employee constructor, and I have a base plus commission employee object. Okay, no new stuff from here. So when I say commission employee to string, okay, question for you: is this a early binding method call or late binding method call? Line 21. Line 21, early binding or late binding? Is it a static call or a polymorphic call? What was the rule for the polymorphism in both Java and C++? Well, the method has to be virtual. Well, in this case, yeah. Well, I know that toString is a. Well, I shouldn't call it virtual, but it can be called polymorphically, no problem. And it has to be called through the base classes reference in Java. Okay, and commission employee is a base class. Yeah. So the answer is early binding or late binding? Is it decided which toString to call during the runtime or during the compile time?
Early binding.
Who said that? Did you talk? You saw? Yeah.
Early binding.
Early binding, why?
Because it's base class.
So well, okay. This is, in this hierarchy, we say that it is base class, but the compiler doesn't know that this commission employee points to a. Compiler doesn't know that the commission employee really points to a commission employee object or the base plus commission employee object, right? I mean, compiler cannot know it without running the code. So this is. I mean, your thought of, okay, this is the base class and I'm using the base classes method. Well, that's kind of correct, but in this case, no. This is the base classes pointer, base classes reference, and I am calling toString method. Okay, and it is polymorphic, and this one is polymorphic too. Base plus commission employee toString. Again, compiler doesn't know really that. Okay, I am really pointing to a base class commission employee during the compile time. It can change during the runtime. So this one and this one, they are really um, resolved during the runtime, and it is late binding examples. How about this printf? Is this late binding or early binding method? Late binding or early binding method? System is a class, out is just a public member of it. .printf, well, we don't actually, we need to look at the definition of it. Most probably it's going to be again late binding. Okay, in Java many things are late binding. Of course, for the static methods they are not late binding, they are early binding. But because for the static methods, okay, there are no objects. Okay, for the static methods there are only classes. Okay, to call this main, you need to call polymorphism test.main. Okay, there are no objects, so there is no resolution. Compiler doesn't, or your runtime code doesn't have to inspect the object and find its type. Okay, for the statics, okay, it is early binding. For the rest of the public methods, it is late binding. Okay, so we looked at this, and I think this was the case where we said this is the another polymorphic example, but this time this commission employee 2 is pointing to a base plus commission employee. Okay, so there is an is a relationship there. Okay, because of the is a relationship, I can do that, and this two thing definitely a polymorphic call. Okay, a polymorphic call. Definitely, whatever you override from the object class, okay, they are all polymorphic calls. They are all polymorphic calls. Good. So let's move on. And let's talk about these abstract classes. Okay. In Java, like in C++, there are abstract classes. So what was the definition of an abstract class in C++? Let's remember it. Somebody tell me the definition of an abstract class in C++.
You cannot create an object.
No. Yeah, well, that's true. I mean, that's the side effect of it. What is the definition of an abstract class?
We have a lot of functions that we don't define.
Yeah.
And after that, we can define.
Sure.
Functions we have virtual functions.
You have pure virtual functions. If you have at least one pure virtual function in a class, that's called an abstract class. In C++. In Java, it's kind of the same, but the mechanism is a little bit different. You put the keyword abstract at the beginning of the class definition. You say that abstract class something. That class becomes an abstract class. So what does that mean? It means that you cannot make objects of that class anymore. Okay. So you declare a class an abstract, or you declare a method abstract. Okay. So in Java there is a keyword abstract, and we don't have such keyword in C++. So a keyword abstract in C++ we don't have anything. We don't have anything like that. But for the abstract classes, okay, in C++, a class with at least one pure virtual function. And in Java, I don't remember any virtual keywords. Okay, in C++ we have the virtual keyword. In Java we don't have virtual keyword, but that doesn't mean that it is missing. So how do you make virtual methods in Java? Everything is virtual by default. Okay, everything is virtual by default, other than the static methods and other than the final methods. You remember the final methods? Yes. A final function is the same, kind of the same thing. A final function means that you cannot override it in the extended classes. In Java, it is the same thing. So, if a function cannot be extended, if a function cannot be overridden, that means that there is no runtime resolution for that method. Okay, so final methods are not late bound. Okay, they are early binding methods. So other than the final methods and the static methods, everything in Java are virtual. Okay. How about pure virtual? Okay. So pure virtual function in Java, in C++. Remember the pure virtual function. In Java, it is called an abstract method. Okay. So how do we make pure virtual functions in C++? We write the function header, and we say equals 0, right? Equals 0. That's the notation of it. In Java, this is how you make a okay, abstract method. Thank you. Okay, line 62. Public abstract double earnings. That's it. So you put this keyword abstract at the beginning of this method definition, and you don't provide the implementation, of course. So this is called an abstract method. In C++, it's called pure virtual function. And this class itself is an abstract class, like this, public abstract class employee. So defining the idea of abstract classes are exactly the same, but the mechanism is a little bit different. That's just the difference. Okay. So let's see what kind of things I am missing here. Okay, keyword abstract. Use to declare a class abstract, and use to declare a method abstract too. Okay. Abstract classes normally contain one or more abstract methods. That means what? You may have an abstract class that doesn't include any abstract methods. This is what you're going to ask, right?
Can we make a file as an abstract?
What's that?
Can we make field as an abstract?
No, of course. Well, what is the meaning of an abstract field?
I don't know that.
No, well, no. Well, abstract method means that it's which method to call will be decided during the runtime, if you call it properly, okay? Because there is a hierarchy, because in the hierarchy I have many toString methods. One comes from the object class, then the employee class, then the other class, and then the other class. Which one am I going to call out of these? Okay, that's the decision to make during the runtime. That's called abstract method. For the fields, we don't override fields, right? There is no such thing as overriding the field. Redefinition of a field. Once you declare the field, it's a field, and if you redeclare it in the extended classes or derived classes in C++, that would be a compiler error. Okay, that would be a compiler error. Yes.
We have to write abstract keyword also class name and functions name. I didn't understand that part. Can you
Yeah, sure. Employee is an abstract class. Okay, this is how you make a class abstract. That's the only condition. Okay, but normally for an abstract class to be abstract, you need to have at least one method that is abstract inside it. But this is not required. If I don't have any abstract method inside my abstract class, that class is again abstract. Okay, so in C++, you can't have this. You cannot have an abstract class that doesn't include a pure virtual function. You have to have at least one pure virtual function to make a class abstract. In Java, all you need to do, put this keyword at the beginning of the class definition. Okay, public abstract class employee, and that class becomes an abstract. That means what? I can't make any objects of this class employee anymore. Okay, even though I can't make any objects of this class employee, I am defining this constructor. Why? Because, and I'm not going to make any objects of employee, right? There is no such thing as new employee. You can't write this anymore because it will give you a compiler error. So why am I writing a constructor then?
Polymorphism?
Well, you don't do the polymorphism with constructors. For the polymorphism to happen, you have to say a dot something, right? You need to call. You can't call the constructor with an object, right?
Maybe it's for derived classes.
It's called what?
Derived.
Yeah, in Java we call it extended classes. Yes, we are going to call this when we write the extended classes, derived classes, right? We are going to use it. Okay, so we are not going to use constructor to make new objects. We are going to use it to initialize our superclasses fields. Okay, so let's go back again. I talked about this, and let's talk about this employee. Okay, remember this nice hierarchy that we looked at, this one in C++. There is an employee superclass. I don't call it base class anymore. This is a superclass, subclasses. Okay, subclass of employee. Okay, of course this relationship is a relationship. Okay, and what else? This operation is called not anymore derivation. We call it extension. Okay, we extend it. Salary the employee extends the employee. Commission employee extends the employee. Base plus commission employee extends commission employee. So such an hierarchy. Let's see what we are doing with this hierarchy. Same table. Remember this table for the C++ example. Employee. We have two critical methods. Okay, those are important too, but we are going to look at them because this will be important. Earnings and toString. Okay, toString comes from the object class all the way up, superclass. Okay, object class is the superclass of all the classes, as you remember. And earnings is the method that returns how much money this objects of these classes are making, right? For the employee, I can't define anything for the earnings because I don't know how much money an employee, a generic employee, does. But for the salaried employee, it's earning a salaried employee's earning is his or her weekly salary. Okay, so how much they are making, it's their salary. Okay, and it's their earnings. For the hourly employee, I need to do this. Okay, I need to take this, look at this calculation. I need to say that, okay, if hours is less than 40, it is just wage times hours. This is times. Well, I couldn't do it, but this is times wage times hour. Otherwise, you need this like that means what? That means I am doing overtime. Mesaiye kalmış, overtime. Okay, and the commission employee, for the commission employee, I just multiply this number. Well, you know the calculation, so it is meaningful for the concrete classes. For the abstract class, it doesn't make any sense. That's why we didn't implement it. ToString is meaningful for all of them because for the employee, even though I don't know how much money they are making, okay, for the ToString, I can at least print the first name, last name, and social security number. For the salaried employee, I print first name, last name, and social security number, and the weekly salary, and it goes like and that and that. So this part is common for all the classes. Okay, so that means what? Whenever I override toString method, I am going to call the superclasses toString method to print the first name, last name, and the social security number. Okay, but when I come to this part, this part and this part is common, see? So because a base plus commission employee is a commission employee actually, and it has more features in it, such as the base salary. Okay, let's look at the class implementation hierarchy. Employee.java public class employee. Okay, this is an unnamed package. I didn't provide the package name. Employee first name, last name, social security number, they are all private. I have my employee constructor. Simple assignments, reference assignments again. Since string is an immutable class, it is okay for me to share these strings with the outside world. So I am not going to make copies of them. I am just doing this reference assignment. That's okay. And setters for the first name, get first name, set last name, get last name, social security number, toString is this. Okay. So again, this string format method, string is a class and there is a format static method. So as you have noticed already, or we talked about already, we use static methods like global methods actually. I mean, it would have been nice to have a method, global method called format that would get a string and do this and then returns a string and etc. Instead, the string class has a format method in it. It behaves like a global method, but of course it's part of string. It's not global method.
So
Okay. Yes.
do we have to write override keywords for toString?
When you override something,
Yeah, toString.
well, as you see, I mean, I am overriding the toString method of the object class, right?
Yeah, but I think I didn't see any override keywords.
So as you see, I didn't write it. Okay. So you don't have to. Okay. So what is the meaning of override keyword? Override keyword says that if you put override here, it means that I am overriding, we talked about this in C++. I am overriding a method. Okay. I know what I am doing. Okay. This is not redefinition. There is redefinition and there is overriding. Overriding is for virtual functions or these kind of virtual methods. Okay. Redefinition is the other type of redefining a method that you don't like anymore. Okay. So this is definitely an override. If you put override keyword in it, it looks nice. Yeah. And if you are not overriding something, compiler will give you, okay, for example, if you have a static method or a final method and you are saying that I am overriding it, the compiler will give you an error message saying that you cannot override this now. Okay, so override is like what? Is like maybe a const keyword. So it is for you to get help from the compiler if you are making a mistake. Okay. So toString is here, and I just call this format method of the superclass class string, and of course my earnings is here. So let's look at the other classes. New class, salaryedemployee.java. So salaryedemployee has to be my public class name. Otherwise, I mean, if you change these two names, one of them is salaryedemployee, the other one is salaryedemployee1, the compiler will give you an error message saying that the name and the file name of the class and the file name doesn't match. They have to be the same. They have to be the same. Why? Because when I compile a file, okay, that file has to have a same named class in it so that the bytecodes can be properly located. So the salaried employee has extra field, weekly salary other than the name, last name, and the social security. So I now get 1, 2, 3, 4 parameters for this constructor, and immediately as the first executable line, I call the superclasses constructor, and the superclass is of course the employee class because I extend my salaried employee from employee. So the employees constructor is called to initialize these three the fields, and then I set my weekly salary. Okay, good. So I have inherited everything about setting names and the last names and the social security numbers, but then I don't have any methods for setting the weekly salary and getting it. So this is setting the weekly salary, including the error checks and getting it, and I am overriding earnings and the toString method again. Okay, this earning is simply returns the get weekly salary, just returns the weekly salary. Okay, and the toString is again calling the string format, but as the first string I am calling the superclasses toString. Okay, I am calling the superclass of toString as the first string, and then I add these two strings. Okay, this is a string, this is a float, as you see. By the way, I didn't have to write this toString here. It's going to work. Why? Because Java always knows how to call how to make a string out of an object. All it does is it just calls the toString method of it. So super.toString and super is the same thing, because this one needs a string in it. Okay. Good.
I have a question.
Yes.
What if there is a two super class, more than one super class?
In Java, there is no multiple inheritance. You have exactly one parent. Your parent might have another parent, right? But usually we don't talk about our parent's parent. We talk about our parent, and our parent talks to their parent. Okay? So there is no more than one parent in Java. There is no multiple inheritance.
Isn't it bad thing for a pure object-oriented programming language?
Well, they say so. Well, I mean, we don't have multiple inheritance, but there are very nice ways of achieving the same kind of mechanism in Java, and we are going to see in a few minutes. I mean, sure, I like to be more than one thing at the same time. I am both a student, also I am a employee too. Okay, this can happen. Okay, if I am an array, I can both behave like an array and a set at the same time. Array set, for example, something like that. So that's done a lot, and in fact Java relies on this a lot. We are going to see some examples of it and how we are doing it. And in Java, they are staying away from multiple inheritance because it has lots of compiler complications. You have to solve lots of problems that makes the compiler a lot heavy, a lot complicated. And if you think about the Java virtual machine, things are worse than C++ case. So they say that we are not going to do the multiple inheritance. They said we have other solution. We are going to look at it. Okay, good. So this is our salary the employee, and we have overridden these two methods, earnings and toString. Let's move on to other class, which is the hourly employee. Again, I extend from employee, and my constructor super set wage and set hours, nice, and get wage is just returning the set wage is setting the wage, get wage is returning the wage, set hours, get hours, and earnings. Okay, so it nicely calls the public interface all the time. If I work less than 40 hours, I just the money I am making is my wage and my hours. I just multiply them. If I worked more than 40 hours, get this number, multiply it with wage. Okay, for 40 hours, multiply it with wage. For more than 40 hours, multiply it with 50% more wage than my original wage. Again, toString says that call the toString of the superclass. On top of it, I am going to add one string, one double, another string, another double. Okay, this is the string for the employee. This is hourly wage. This is get wage. This is hours worked, and this is get hours. Good. So that's the two method definitions. Do the same thing. Commission employee extends the employee. Okay, I'm going to be a little bit quick here. So earnings is just for the commission employee. Earnings is just get commission rate, get gross sales, and this is the toString. Maybe a little bit more interesting is this one. This one is extending the commission employee, not the employee, but extending the commission employee as the base salary. So setter and the getter for the base salary plus these. See, super.toString is calling the commission employees toString method. Good. So I have written class definitions for 5 classes, employee and 4 extended classes. Now let's write some driver code. Okay, payroll system test. Okay, it will include our main method. Okay, I am making 4 objects: salaried employee, hourly employee, commission employee, and base plus commission employee. I made 4 objects. Of course, there are no objects of employee class. No problems there. Okay, so I can do whatever I want. So employee processed individually. I am calling, see this one, printf string float. Salaried employee is not a string, but the compiler knows how to make a string out of a salaried employee. How? It is calling its toString method. Okay, and this is earned, and this is of course a double. Okay, and hourly employee, the same thing, commission employee, and everything. Okay, so these are all polymorphic calls again, because I am calling them through a class's reference, and earning is a late binding method. But in all of these cases, this is the earning of the salaried employee, earnings of the hourly employee, earnings of the commission employee, and earnings of the base plus commission employee. I know, but compiler makes this decision during runtime. Kind of seems inefficient, but that's how Java works. And then we are doing this. This is interesting. So I have what do we call this? This is an array of what? Array of? No. Array of employee references. Okay? It's not an array of employees. In Java, you can't make array of employees. Okay? You will have to make an array of employee references.
Because of abstract class.
What?
Because of abstract class.
No. Because in Java there is no, this is not, let's say commission employee CE. What is CE? CE is an commission employee reference, right? You cannot make objects like this in Java, okay? So all you can do is you can have commission employee references, okay? So using the is a relationship, I can assign these references to these references. So this is a reference assignment, all of them. These are not object assignments. In Java, we don't have object assignment. All the assignments are, okay, for the objects, reference assignments. You cannot assign an object to another object. Okay? Of course, for the fundamental types, for the primitive types like integers and doubles, there is no references. Okay? They are all fundamental types. When you assign an integer, for the fundamental types, it is very, very much like C. Okay? Assign an integer to another integer. But for the objects, you cannot touch objects with your hands in Java. You have to use the references. You have to use the handles. Okay? So I have 4 references: salaried employee, hourly employee, commission employee, base plus. And I make these assignments because there is an is-a relationship, right? I know that all the salaried employees are employees, so I can make this assignment. Opposite is not true. Not all the employees are salaried employee. Not all the employees are hourly employee, right? But I know that some of the employees are hourly employee or salary employee, but not all of them. But all the salaried employees are employees. Is a relationship, is a one-directional relationship. Good. So I did this. Good. So let's look at, maybe you have guessed what we are going to do. We are going to run this nice loop Did you see that? Line 44. An enhanced for loop or range-based for loop in C++. Did we write this in here? Did we write this enhanced for loop range? Yeah, range-based for in C++, enhanced for in Java. Yesterday, I think, yeah, this is reference. Okay, there was an error in it. Okay, did we miss anything in here? Virtual, abstract, an abstract class. Yeah, okay, good. Okay, so enhanced for loop, this employee reference current employee iterates over the employees one by one. And line 46 is a very typical polymorphic call. Okay, what do you mean by polymorphic call? All I am saying is the print line, and I don't know if print line is a static method or something like that. Probably a static method, probably. Okay. Other than the how many method calls do you see on line 46? While you are thinking about it, I am going to resolve this issue of print line. I am going to make the Oracle print line. Let's see what kind of definition print line system that out. Okay, yeah, I think I can find it from here. I am going to look at the definition of print line to see if it's a static method or not. So this is system. Inside the system there has to be, these are the methods, these are the fields. Yeah, out is here. Out is a static print stream. Okay, out is this one, print stream. Okay, let's go to print stream. Inside the print stream I am going to see all the methods of methods, append, print. Yeah, these are all nicely written. You know, these are not static. These are all print line. Yeah. See, print line is overloaded for all the basic types, right? So that's it. So how do we use this? We use the print line with a string then, and Java knows how to convert anything to a string. Okay, if it's an object, otherwise it uses these fundamental types. Okay, let's go back. So there is a function method called there. How about this one, current employee? Current employee is in the string, and I don't see any print line methods. How about this? Can we overload print line so that it works with employee class? Overload print line so that it works with employee class. Like that, okay? So they have overloaded this print line for booleans, characters, arrays, doubles, and etc., right? Can we overload the print line so that it works with the employee objects? Would it be a solution?
No.
What? Who is talking? Yeah.
I think it's not working.
It's not what?
It's not working for current employee.
Why not?
I don't know.
Any other guesses?
I think it's not allowed.
You are not allowed to modify this class print what? What was the name of the class? Print stream. Print stream is not your class. You cannot modify this class. You cannot add any method to it. It's different from C++. In C++, usually we write global function that takes print streams and etc. In Java, you can't do that. The only thing, maybe one thing you can do is extend print stream with your employee, extend your print stream, employee print stream, and add a print line method to it, but that would be an ugly thing. Instead, I have this. So instead of calling current employee dot string to string, it just makes just current employee and that's it. So the compiler calls current employee to string, but compiler realizes that during the compile time, I don't know what toString method to call because I have, how many toStrings did I define? There are 4 classes, of one for the employee too. 5 toStrings, right? And one comes from the object method. Total of 6 toString methods are there, right? So compiler has to make a selection out of those because the compiler doesn't know, okay, what kind of object this current employee is pointing to, okay? It has to make this decision during the runtime. So how it is going to do that? It's going to look at the type of the current employee object, and it's going to say that for the index number 0, it says salaried employee. So I am going to call the salaried employees print method. Typical polymorphism working here, okay? So this line 44, 45, and 46 are the lines that work like a generic piece of code. This is as generic as it can get, okay? This is as generic as it can get. So this loop will work all kinds of employees, whatever they are. Very generic piece of code. But like in the C++, if you like to write specific code, okay? I like to run this loop, but also I like to say things. Okay, print all the employees using their own methods, but for the base plus commission employees, I am going to do something specific. What did we do in C++? We used the dynamic cast to cast the object or reference to the correct type. If we get the not null pointer, then we said that, okay, we have our cast successful. Otherwise, our cast is not successful. So I am going to assume that this is not the right object. And how are we going to do the same thing in Java? This is how we are going to do it. We ask this question. There is an instance of operator in Java. Okay? Instance of operator in Java. It says that is current employee, this one, is the current employee an instance of base plus commission employee class? Okay, this will return either true or false. If it returns true, that means what? I am referencing to a base plus commission employee, and then this is what I do. Typecast. This is the only place where you use the typecasting in Java actually. Current employee to an employee. So this is called what? What casting? Current employee, okay. Current employee is casted to employee. What kind of casting is this? Downcasting, right? It was the same terminology that we use in C++. Okay, it is called downcasting. Okay, because current employee is an employee base plus commission employee. I am downcasting this reference to base plus commission employee class. Downcasting. Upcasting is always okay because there is a relationship. Okay. For the downcasting, I have to be careful. I checked if this downcasting works fine. Say that yes, your current employee is actually a base plus commission employee. Okay, so I did the downcasting, and after that, I know that this employee now is a base plus commission employee. Okay, so on the employee I can call get base salary, and I set the set base salary, and that's it. So what did I do in effect? I kind of gave a raise to the base plus commission employees 10%. 10% raise, okay, 10% increase in their salaries for the base plus commission employees only. For the others, I didn't do anything. Okay, and by the way, yeah, this one is a polymorphic call too. System out printf current employee.earnings. How many earnings method did I define? 1, 2, 3, 4, right? And the compiler doesn't know which one to call during the compile time. Out of door 4, anything can happen. Okay, out of door 4. For the employee class, it was an abstract method, so I didn't define it. So the compiler is trying to figure out which one is the call. So during the runtime, it says that what is current employee? Is the base plus commission employee, or the commission employee, or the salaried employee? What? Okay, it gets the type, it calls its earnings method. And that's the end of the for. So this part of the code is specific. We don't write this kind of code, very specific code. Specific code. Okay. We like to write this kind of code. This is generic. Because this code will work for all employee types, and this code will work for all employee types. Okay. Doesn't matter. This one is going to work for only base plus commission employee. If you need to, yeah, you are going to do it. Remember what our book said about doing this kind of stuff? They say that don't do downcasting, it is dangerous, and etc., etc. Well, I mean, I don't agree with it, and I don't agree on that on Java too. If you need to, you do the downcasting, but you need to be careful. So do the type check first. In C++, we do the type checking by looking at the pointer returned, if it is null or not, after dynamic casting. In Java, before doing this casting, I use this operator. If you don't use this operator, I think this is going to throw an exception. Okay, any questions so far? And if I run this program, by the way, there is another one here, okay? For 0 to employees length, I am going to call the, remember there was a get class method in object class? Get class returns a object of type class with a capital C, and there is a get name method in it. So this will print all the references class names. Okay, so these are all printed. These are all printed at the end. Employee 0 is a salaried employee. So these will come from the get class get name. Get class get name. Okay, all the objects know their class names. Okay, are there any questions? Any questions from the online audience? Online audience? Nobody's talking anymore. The online audience. How many people do I have? 40 people. And around 30 people here, total of 70. Not bad for the end of the semester, yeah. Okay, so let's come back around 10:35. Okay, and we will continue after that. So 10 minutes of break. Did everybody sign this sheet? Did everybody sign it?
Nasıl? Bilmiyorum. Hocam onda bonusu nerede falan? Bu arada kayıttayız değil mi?
Hocam gelince söyleyelim ama şimdi baksın daha güzel. Götürdü mü acaba? Götürmüş mü? Herhalde götürmüş. Gel bunu da bir sorayım. Biraz daha erken geldi de son 15 dakika için dersi bölmeyeyim dedim. Dışarıda yapalım.
indiriyor kanka. Her dersin sonunda izliyoruz hep gördüğüm ben. İzleniyor korkmadan önce. İzleyenler de yaparız.
Bu konstant olanıyla çok bir farkları yok. Şimdi konstanta sadece şimdi normal pointer kullandım. Şey Gebze'nin her yerde pointer kullanılıyor ama
Her yerde dememiş kanka.
Yok şeyde ya demiş. Kazanımızda
Vektör aynen array'de falan.
ama o iteratör klasında member oluyor. Ya öyle olması çok saçma zaten de.
O ayrı bir şey.
O farklı bir klasın şeyi.
Yani orada normal pointer kullanmamız lazım. Arttırılmıyor bile şehir pointer. Şehir pointer olmasa daha iyiydi ya. Ben sevmedim.
Bence almak direkt kuru olarak yanlış oluyor.
Şey pointer iterate olan şey iteratör olan nasıl öldürdüğünü
Ben sana şey göstereyim, bende şey vardı.
Bak şimdi, bu bitecek.
Şimdi aklıma geldi.
Bir sürü yeni şey aynı anda kullanmak
Ondan sonra 2 günlük şey var işte. Evet.
Ay kolay.
Uzun bayağı. Baksana.
Bu mu?
Ayrıntılı.
Ben bu kadar bilmiyorum.
Test ettim yani.
Şey ne?
İteratör hariç.
Tam bunun size'ı ne olacak? Ben de memory aldım.
Bir gün sadece dışarı çıktı.
Ya ben bir tane fonksiyon yazdım. Yaratık diye. Bir şey yazdım. Onun işte bir kontraktı çağırıyor.
Ben de odaklandım.
İşte
Ben de odaklandım.
falan çağırırken kontrol ediyor. Nasıl bir çağırıyor?
Evet, ona kendim mi yapıyorum? Kendim mi yapıyorum? Sen operatörler de yapıyorsun. Sen sadece zaten fonksiyonları ekliyorsun herhalde.
Zaten
Yapıyorsam yeterli.
Puan kurar bence. Yani vektör koymak istemiş.
Tamam da vektörün bir tane konusunda hepsini yazıyor musun? Bayağı var vektörün.
Yani
Ben
15 tane falan vardı herhalde.
Şeyi mesela yazıyla böyle edit perspektifi kullanıyorum. Edit demişler.
Biraz geç kaldı da polymorphism olur mu?
Daha sonra. Okay, so instance of is an operator. In Java we have it. In C++ we don't have an instance of operator like that. And with the instance of operator, you may ask questions about is this object an instance of this class? And by default, of course, any ref, okay, instance of object class will return true, right? Because all the references are instances of object class, because there is a relationship and all the objects has to be extended from the all the classes have to be extended from the object class. Okay, so dynamic binding, late binding, we know what kind of things they are. We talk about that. This is the basis for the polymorphism, and remember the polymorphism is the many faces. This function call current employee toString. I know the meaning of it only during the runtime. So dynamically I can determine the meaning of current employee toString, or dynamically I know the meaning of current employee.earnings, okay, during the runtime. So that's the polymorphism, just writing generic code. And you already know that because you did your homework in C++ and you did your we have seen this working for C++ in our examples. Okay, so even though it's a very important concept, it is one of the main pillars of the object-oriented programming philosophy, polymorphism. I am not going to talk about it much. So I only talked about it for the mechanisms of Java, how we do the polymorphism in Java. Okay, so instance of operator needs to be used if you are using the downcasting. Okay, if you are using the downcasting, just the direction opposite of the is a relationship downcasting. to cast it correctly, you need to ask this question first. Am I an instance of this class? If it is, then just downcast it. Okay, so we talked about this. Allowed only if the object has a relationship, otherwise it doesn't make any sense at all. And I talked about this get class. It's going to return an object of type class, and inside that class there is a get name. Other than get name, what do we have? Other than get name, what do we have? So Oracle class object class, and I'm trying to figure this out for the get class. Okay, class. There is a class named class, which is very confusing, but I didn't design this language. And inside, okay, there is a get name. Okay, this is the class, right? Okay, class. And where is get name? Yeah, get name is here. That returns it. So it returns its package, its name, modifiers. Oh, that's interesting too. Okay, returns the Java language modifiers for this class. So is it a public class or not public class, and etc. And you can get the methods of a class too. See, this is a method array. This is a method array. Get the methods of this whole class. So your methods can be called separately. Okay, so the lambda methods are available for Java too, and I'm not going to talk much about them. So read this kind of documentation. Many things will make sense, many things won't make sense. So learning new stuff means this. Okay, put together all the stuff that makes sense, and put together all the stuff that doesn't make sense. Try to compare them and try to understand the stuff that doesn't make sense by yourself. And if you can't, just ask questions around. Read Stack Overflow, ask questions in Stack Overflow. This is how you learn a new language. Okay, good. So let's move on. Final methods and classes. Final classes are the classes they cannot be extended by a subclass. If you say this class is a final class, okay, then nobody can extend that class anymore. So it doesn't make sense. It doesn't make any sense to make an abstract class a final class, right? I mean, you have an abstract class, which means what? I cannot make objects of it. Why am I making an abstract class then? Because I like to make it a superclass of some class hierarchy. So if you make that class a final class, then that doesn't make much sense. And I am not sure if it is possible. Both abstract and final, the compiler might object. Final methods are the methods that cannot be overridden. Okay. Private and static methods are implicitly final. Okay. So why did they make the private methods final? Because I cannot override the private method. Why? Because I can't call them, right, in the extended classes. I can only call the protected ones and the public ones, right? They are not accessible for me in an extended class, the private ones. And static ones are actually, they don't need an object to be called, so they are final and they cannot be extended, overwritten. Okay. And why are we talking about these finals in all of a sudden? Why is it so important to have this? Because final methods are resolved at compile time. So these are the typical C++ functions. Okay, C++ functions by default are non-virtual, right? To make a function virtual, you put a virtual keyword in it. In Java, it is just the opposite. Okay, everything, all the public methods are public and protected methods are virtual in terms of C++ terminology. If you don't want to use late binding for these kind of methods, you declare them as final. Okay. So if you declare a method as final, so it cannot be overridden, And the compilers can optimize by inlining the code. That's another thing we didn't talk about this in C++. You cannot inline a virtual function. Why not? There is no inlining of virtual functions in C++. It is not possible. What was inlining? Inlining is putting the code in instead of calling it, right? Remember, we make the getters and setters inline so that we get rid of the call overhead, function call overhead. But you cannot make a virtual function inline. Why not? You cannot make a virtual function inline.
We don't want to touch. We have to define, redefine. So first of all, we don't write an inline function.
Because when we write that code, we don't know which function to be called. Okay. Since we don't know which function to be called, I cannot inline it. I cannot copy the code and paste it in my code, right? So it is not inlineable. Okay. If it is not virtual, then it can be inlined. So it's a way of kind of optimizing your code in Java. So it's a, well, I mean, this detail is not that important, maybe if you are not after optimizing your code, but this is important to understand the behavior of the polymorphic calls, virtual functions, polymorphism, inlining code, and if you like to know about like to understand all of these concepts at the same time, then this sentence is a very important sentence, both Java and C++. Okay, so if you didn't understand, just read it, just listen to the video again. Okay, any questions so far? Well, in fact, that would make a very nice exam question. I hope I don't forget and ask this question. Yeah. Okay, so if there are no questions, I will start a related but different topic. In Java, there is a concept named interface. Okay, they just called it interface. Maybe it's an unfortunate name, but its name is interface. So people usually are confused with this interface and our class. Remember, in C++ we had the class interfaces, our header files, and etc. In Java, there is a separate keyword named interface. So don't confuse the don't get these two concepts mixed up. Okay, the Java keyword interface. Interface is actually, they don't like it to be called this way, but interfaces are special classes, Java classes. Inside these classes, all the methods are abstract. Okay, all the methods have to be abstract. All the fields are public, static, and final. Okay, so all the methods are implicitly public, abstract. All the fields are public, static, and final. Very weird stuff, right? So you cannot have a variable. All the variables are public. All the variables are static and final. And all the methods are public, abstract. You cannot implement any methods in it. Okay? And as I said, it's a special kind of class. And Java people don't call them classes, but just to be able to remember it. So in C++ we don't have interfaces. Okay, we don't have any class type that corresponds to these interfaces. If you like to do the same thing as the interfaces in C++, you define an abstract class. All of the methods are pure virtual, and there are no data members, okay, non-static, non-constant data members in it. That would kind of correspond to interfaces, but of course it is not the same thing, but if you like to do it that way. So classes, regular classes, you don't extend, you don't, of course, I mean, if you have such an abstract class, such an abstract thing interface, it is more abstract than an abstract class, right? You cannot implement anything in it. So if you have such a thing, what are you going to use it for? You cannot make objects of it, obviously. You are going to extend them, okay? But in Java, you don't extend them, you implement them. So there is a keyword, a separate keyword named implement. It is different from extends, okay? It's called, okay, implement, and the classes implement these interfaces, okay? And normally, like regular classes, these interfaces have their own Java files, but instead of saying public class my class, you will say public interface my interface. Okay, so that's the interface. Let's look at this one. Okay, I am going to make an hierarchy. At the top there will be an interface, payable interface, and this will be my hierarchy, very simple hierarchy. Payable interface, by the way, we represent, we mark all these interfaces with this code sign interface, okay? So they are written differently, and this invoice and employee, okay, they don't extend payable class, they implement payable interface. That's why you have this dashed lines, okay? Salary the employee extends the employee. This is inheritance, okay? This is extension. This is again inheritance, but this is implementation, we will call it, okay? Invoice and employee implements payable. Salary the employee extends the employee. Okay, good. So let's look at this one. By the way, remember our Java collections hierarchy? Java collections hierarchy. Let's look at this one. And inside the Java collections hierarchy, I think this is a, and some of the classes use a different color. The reason why we have, no, these are not good. Let me have this one. Maybe this is better. Yeah, this is better. Yeah, okay, good. This is from Wikipedia. Okay, this is just collections. At the top I have iterable. Iterables are interfaces. Abstract classes are blue, and concrete classes are this color, whatever it is, reddish, purplish color. Okay, so this tree set, linked list, array list, these are all concrete classes. These are all interfaces. This is an abstract class, abstract class, abstract class. Okay. So this one is interesting. See, this tree set is both a navigable set and it's a abstract set too. Well, remember what I said? I said that there are no multiple inheritances in Java. Well, yeah, that's true. There is no multiple inheritances in Java, but you may implement as many interfaces as you like. You may implement as many interfaces as you like. So this abstract list extends this abstract collection class, but it implements the list interface. Okay, similar stuff can happen. So this is the way they formed it. At the top there is very abstract interface of iterable. Iterable means it's like iterator kind of thing. So I can use an iterator to move on these objects, okay, on these objects of these classes. So iterable has, I mean, in Java we don't have, obviously we don't have the plus, minus operators. We have the next and prev methods. So iterable has this in it. And if you are extending this iterable, if you are implementing this iterable, you have to provide it. Of course, collection is another interface. So interfaces are, there is a relationship between these two interfaces. Okay, so In C++, it is not possible to draw such a figure. In C++, we only have abstract classes and the concrete classes, just two colors. In Java, you have interfaces. So I know that there is definitely no implemented method inside this interface. No implementation. But this is an abstract set. This is an abstract class. I know that at least one method is implemented in it, right? That's why it's a class. It's not an interface. So let's go back and let's try to do the same thing. Okay, here, by the way, well, they didn't show it here, but usually we use a dashed line to show the implementation lines, and the solid lines for the is a relationship, or the not is a relationship, or for the extension lines. Okay, so they didn't do it, but here we are doing it that way. Okay, so this hierarchy is very simple. Payable means that that's it. This is our interface. Public interface payable Java. Okay, no implementation. I didn't say this is public, private, protected, because what was the rule? Everything inside an interface has to be public. If it's a method, it has to be an abstract method. But I didn't write abstract method something like that at the beginning. I know that it is interpreted that way, so I don't write it usually. Okay, usually you don't use the modifiers in interfaces because I know that everything has to be public. So payable, public, get payment amount. So payable means that it's the thing that I can pay. I can pay an invoice, fatura. I can pay an employee. I can pay a salaried employee. Okay, so how much money I'm going to pay to you? This much. I can pay that money to an invoice or employee. Okay, for the employee I pay their salaries. For invoice I pay the invoice amount. Fatura miktarını bunu ödüyorum. Employee'nin kazandığını bunu ödüyorum. Okay, so that's the top of it. And let's look at our regular hierarchy. Okay, see, class invoice not extends but implements payable. Okay, class invoice implements payable. If you are implementing more than one interface, you will say implements payable, comma, this and this, comma, this and this and comma. You may implement as many interfaces as you like. Okay, let's go back and let's talk about this multiple inheritance problems. In C++, let's say I have a person class. Inside this person class, of course, I have what? I have get name, right? It's a person. Nice. And from this person, let me put it here. I have to the derivation. Okay, I have student. Okay, and this one has get GPA. This one I am going to do another one, employee. This one is get salary, right? Good. What if I like to make this derivation student employee? We have students at this university. Okay, both they are students and they are employees. So they have their GPAs and they have their salaries too. Okay, but the thing is this. Okay, I inherit this get name, and by the way, there is a minus string name in it, right? I have inherited this string name through this path, also through this path too. Two paths, and I'm inheriting the name two times. That's going to create lots of problems. I mean, repeating the same thing twice, memory problems, etc. Compilers has to be careful about this problem. So this makes C++ compiler a lot more complicated than it needs to be. Java solves this problem. Java says that no multiple inheritance. No multiple inheritance. We don't have this problem. You can have only one parent, not two parents. Okay? You can have only not two parents here. You can have only one parent, so there is no such a problem. Inheritance through different paths problem. So, but then I told you that I can implement more than one interface. What's the problem there? The problem is this, okay? I don't have that problem here because if this is an interface, this gate name cannot be implemented, right? And if this is an interface, this string cannot be a variable, it's a constant. Okay? So it doesn't matter if I inherited 2 times, I am just inheriting the name of the method. And I am inheriting a constant variable. Okay, if you like to call it that way. So it doesn't matter how many times I inherit the constant, it's the same constant. It cannot change. Okay? So inheritance doesn't have this problem of inheriting the same thing more than once. This one, get name, is not implemented. Okay? It is not implemented there. Okay? And if I am doing this, both of them are interfaces, I can get these both. Okay? And if these are both interfaces, then none of them can implement get name. Anyway, this one is going to implement it. So Java doesn't have this problem. That's why you may implement as many interfaces as you like. No problem. And Java will use this feature in many places. It relies on this feature in a number of places. And most of the time, instead of using derivation, okay, instead of using regular extension mechanism, it uses this implementation mechanism. Implements first interface, second interface, and etc. So this is what you do. Okay. Public class name extend, superclass extend can only extend one class, but I can implement this interface, this interface, this interface, and that interface, and etc.
Sir, could you repeat the last part?
Which one you mean?
Interface.
A Java class can extend only one superclass, but it may implement more than one interface. Okay, let's go to oracle.com. Where is my Oracle? Okay, here it is. Let's go to the package. Okay. For example, our favorite, let's look at this string. Yeah, okay, good. String. It says that string, okay, extends class, a Java object class, which is obvious, everybody has to do that. But it implements serializable character sequence and comparable interfaces. Okay, so that's the definition of string class. Public final class string. By the way, class is string is a final. You cannot extend it. What happened? Come back. Yeah. Okay. It extends the class object, but it implements serializable, comparable, and character sequence, and we are going to see what those mean in a few minutes. Okay, good. So did I answer your question? Okay, so as you see Java uses this is a relationship a lot, because every string is a serializable. Every string is now an object, I know that, but every string is now a character sequence. Every string is now a comparable. Okay. Every string is now comparable. And we have many examples of it like that. And let me open this array list. Do I have array? Where is my array list? Oh, okay. This is a Java lang package. Remember Java lang, which is important automatically. Package. And okay, this is okay. This is the overview. These are all the packages. Do I have the I don't have the collections array list stuff. I don't have it. I'm trying to find the array list, which is one of these. Okay, this one array list here. So maybe I should type okay, let's go to array list, class array list, and let's see what kind of okay, good. So array list extends abstract list, which in turn extends abstract collection, and that one extends object. So this extension hierarchy, there is always one parent. But array list also implements serializable, clonable, iterable, collection, list, and random access. Okay, and this one is called. These are the subclasses, the classes that extend array list. So you will see this kind of crowded inheritance hierarchy and crowded implementation hierarchy in most of the classes. Okay, let's go back and let's look at this very simple payable. Okay, you might say that just a single line of code, I mean, what is so big deal about it? But when you do this, all the classes that extend or that implement this payable has to provide this get payment amount method. It's implementation. Okay, if I have a payable array, payable reference array, I can call this get payment amount in each of them, and it will work. Okay, so this is invoice. It implements payable. It's a concrete class, not an abstract class. So for the invoice, I have the part number, part description, quantity, and price per item. And I have my constructor here. String part, description, count, and price. All the assignments, set part number. These are all the setters. Setters and getters and etc. And we implement toString, well, nice written. I am overriding the toString method of the object class, and get payment amount is the quantity times get price per item. So this is the payment amount for the invoice. How about the other side of the hierarchy? Okay, well, see, employee is a class, but it's an abstract class, and it implements payable. Why is it abstract? Because I don't know what to write for the get payment amount. Since I am a payable, I need to provide the implementation for the get payment amount, but I don't know how to write it. I am too generic now. So everything is the same as before, setters and getters. And as you see at the end of this class definition, I don't have any method implementations for the get payment amount. So that means what? I did not provide it. I am an abstract class. Only through the new extended class of salaried employee. Salaried employee extends the employee, but salaried employee actually implements payable too. So I call my super constructor and everything, and my get payment amount is get weekly salary. That's it, and auto string. And after I am done with this, let's write some test code. Payable interface test. See, I have a payable reference array, an array of payable references of size 4, and I have added 2 invoices to it. Okay, 1 seat and 1 tire. I have 2 seats, each one is costing this much, and I have 4 tires, each one is costing this much. These are 2 invoices, and I am adding 2 salaried employees. So I can put all of them in the same array, because array is a payable reference array. Okay, it's a payable reference array. Okay, so I did this, and as you are expecting, I am going to run a loop on this payable array and nice enhanced for loop, payable current payable objects. Okay, on each of the payable objects I am calling toString method and get payment amount method. So polymorphism as basic as it can get. Okay, and it is running this polymorphism on this payable objects. So the inheritance is almost the same as before, no problems. The thing is that I can do this implement stuff. Where is it? Yeah, this implement stuff done for the interfaces. Okay, so the advantage of interface over the abstract classes is I can implement as many interfaces as I like. I can behave like a payable and comparable and etc. And as I said, Java uses this, and in almost all the things that I see, well, these are comparable. Remember the string? String implements comparable. What is comparable? Comparable is I can compare two string objects. Okay, so if a class implements it, I can definitely know I can sort those. I can sort those objects that implement the comparable stuff. And in fact, let's look at some of the standard Java interfaces. For example, one of them is this comparable. Comparable is a standard Java interface. Okay. In that interface, comparable interface, you need to implement one method. It is compare to. Okay, compare to. Compare to compares this object with the given object, the other object, and it returns 0 if those are equal. It returns -1 if the first one is less than the second one, and the +1 just the opposite. It is like strcmp, right? strcmp works this way. It is either negative, 0, or positive. Okay, so if a class implements comparable, it needs to provide this compare to method. If I know that a class is a comparable class, if it implements it, then I can sort objects of that class, right? Because it knows how to compare itself with others. If my day of year class is a comparable, then I can write a sort method. A sort method, okay, it takes an array of comparable objects. Okay, that's it. I can call the sort method with any array of comparable objects, including the strings, including the day of year objects, including the gradebook objects, as long as those objects implement comparable interface. And the compiler knows if they are implementing or not, right? Because at the top of their array class header, they say that I am implementing this comparable interface. So again, this is as generic as it can get, because with this sort method only assumes that this array elements implement the comparable interface, which is implementing the compare to method. What else? Serializable interface is a tagging interface, actually. Let me write the serializable interface for you. Interface serializable, okay, open curly brackets and close curly brackets, public interface. That's it. It doesn't have anything in it. These kind of interfaces are called tagging interfaces. If you are implementing the serializable, you don't have to do anything. You just say that I am a serializable. Serializable means that I can be written to the disk. Okay, you may write my object to the disk and read it again. No problem for me. Okay. So writing an object to the disk and reading it, sometimes it is not possible for some classes if they are using lots of dynamic memory. Sometimes it is no problem. So our money class or the day of year class or the gradebook class, they are all serializable actually. If you like to make them, they are just serializable. So this is called a tagging interface. What else? What else? We are going to talk about them. Sometimes we put lots of constant inside the interfaces. Okay, I don't use the interfaces for class hierarchies in this case. I put lots of constants in them. For example, saving constants, color names. Red is, okay, 25500. Okay, that's called red. Pi is this much, this, okay. So sometimes instead of putting methods in it, sometimes I put, remember all the fields have to be public static final. So sometimes I use that too, saving constants.
So runnable is very useful for asynchronous in mobile development.
Well, runnable is how you do multi-threading with Java actually. I mean, Java supported multi-threading from the very beginning, okay? Starting from C++ 11, C++ by standard supports multiple threads, but we are not talking about them much because, I mean, multiple threading is, of course, multi-threading is very important, but they are out of the scope of object-oriented programming. You are going to look at them when you take the systems programming and operating system courses. Okay, good. Remember that clone method that we had in the object class, clone method, and by default that clone method is protected. If you like to make your classes clonable, then you need to override that method and make it public. But to make your classes clonable, you need to implement this clonable interface. Inside the clonable interface, there is only one method, it's called clone. Okay? So, sorry, that's not true. Inside that clonable interface, there is nothing. It's just clonable. It's a tagging interface, okay? If you look at the clonable definition, yeah, here it is. Okay, clonable, that's the whole documentation. What do I inside the clonable? Nothing. Okay, there is nothing. Okay, so you are saying that to the compiler that I can be cloned. That's what you say. Tagging interface again, like serializable. You are telling the compiler that I am clonable. If somebody wants to clone me, they can go ahead and in fact you can clone me too. So I am going to show you one example here with the cloning objects, clonable, and but I am going to do that not tomorrow but on Wednesday, and after that I think we'll be done with Java maybe. So I need, how many classes did I miss this semester? How many classes did I miss? So I think I am going to make 1 or maybe 3 hours of lectures on Monday morning. Okay, classes are over this week. Next week is make-up time for the missed classes. I am going to do a class on Monday morning for 3 hours, and I'm going to show you some graphical user interface stuff. Okay, 3 hours should be enough for us. Because your last homework will be about graphical user interfaces, so I need to do that. Good. Okay. Are there any other questions? Tomorrow morning we will hear Mustafa will come here and he will talk about his experience in about object-oriented programming in his professional software engineering life. Good. Who did not sign the attendance sheet? Birinci.